anti-aromatic. Okay, so aromatic means it makes the compound highly stable. It makes the compound highly stable. It makes the compound unstable. It makes the compound unstable. Okay, so this is the condition. That is, compound will be either stable or unstable. That depends on the presence of the aromaticity. So now, how to know whether the compound has aromaticity or not? So in order to know aromaticity, we have to apply, or we have to take the help of Huckel's rule. We have to take the help of Huckel's rule. The Huckel's rule कौन? What is Huckel's rule? So Huckel's rule under रे किसी points अच्छी. So we are going to discuss those points one by one. First, compound should be cyclic. So I'm going to compound देखिए कहीं पर whether that is chain compound or cyclic compound. So this is the very first condition. In Huckel's rule, the compound should be cyclic. अब मन रखो, Huckel's rule is useful for explaining whether the compound is aromatic or anti-aromatic. Okay, both aromatic and anti-aromatic can be decided by taking the help of Huckel's rule. So the compound should be cyclic. देखिए compound जानी पड़े cyclic के नहीं. Second condition कौन? Now that is cyclic है, then the compound should be planar or nearly planar. The compound should be planar or nearly planar. Okay. तमने आमे प्लानरिटी देखि जान परिबा गोटे कंपाउंड देखला कहि परिबा सेटा प्लानर कि नियरली प्लानर सेटा देखि के हम इजीली कहि परिबा. ओके, सो इट इज द सेकंड कंडीशन. थर्ड, the compound should be fully conjugated system. Fully conjugated system. Okay, so गोटे कंपाउंड देखि कहि परिबा ना सेटा fully conjugated कि नहीं. Yes or no? जेमि हम जानछे conjugation means pi bond in conjugation with pi bond in conjugation with positive charge, pi bond in conjugation with negative charge. हम जहाँ भी condition जानछे. So all are known as the conjugated system. So the compound should be fully conjugated system. Conjugated हेले कौन होगा? ना the movement of electron will be continuous. The movement of after checking these three conditions. Okay, after checking these three conditions, तापर हम देखिवा whether the compound is aromatic or not. So तापर next condition कौन? ना fully conjugated परे आमे तापर next देखिवा fourth A for aromatic. If the compound is aromatic, ताल कौन होगा? ना केम जानिबा? ना 4n plus 2 pi electrons. If the compound contains 4n plus 2 pi electrons where n value starts with 0, then it is aromatic. Second, for anti-aromatic, 4n pi electrons where n value starts from 1 here. N value starts from 1 here. Okay, clear? So this is these are the points coming under Huckel's rule. The one late join student I am going to recap. First, we are going to discuss the topic aromaticity and electrophilic aromatic substitution. So aromaticity can be either aromatic or anti-aromatic. जदि गोटे कंपाउंड रे aromatic अच्छी then the compound is highly stable. जदि compound anti-aromatic अच्छी then the compound is unstable. So आम decide केमती करिवा whether the compound has aromaticity or not. So in order to know the presence of aromaticity in the compound, we have to use Hockel's rule. So what are the points coming under Hockel's rule? Now first compound should be cyclic. आम देखु दो जानि परियो गोटे compound cyclic अच्छी कि chain अच्छी. Second, planarity must be there. Planar or nearly planar. तमे एक condition भी जानती हो जेतोला में resonating structure देखुतिले. So in order to make the resonance possible, planarity must be there. But a compound if planar thibo or nearly planar thibo, then only resonance is possible. Without the planarity, resonance is not possible. The reason kono? Now, for movement of electron in different planes, more energy consumption will be there. Okay. ताले एठी कोन हबो ना एनर्जी कंजम्पशन बहुत कम थिबो. सो सेटा ल तमरो प्लानारिटी रो. तो प्लानारिटी में एमती जानि परिबो sp2 हाइब्रिडाइज थिबो आदि. तो सबटर इजीएस्ट वे हला जदि sp2 हाइब्रिडाइजेशन अछि ताल से प्लानर हबो. ता नेक्स्ट वन फुली कंजुगेटेड सिस्टम. हमें एग्जांपल देखिबा. ता जदि एरोमेटिक अछि सो इट मस्ट हैव 4n + 2 pi. So n value starts from 0 and the anti-aromatic अच्छी it must have 4n pi electrons. N value starts from 1. Okay. So up to this clear. Now we are going to discuss some examples. Now without example हमें जानी परिवानी. So we are going to take few molecules. तार हमें aromaticity check करिबा. This I would point student it add करि परिबो. Note करे add करि परिबो. If lone pair or negative charge is the part of conjugation, then it is considered as 2 pi electrons for deciding aromaticity. An example देखिए. If lone pair or negative charge is the part of conjugation, हैला. So हमें aromaticity decide करिया पे it has to be considered as 2 pi electrons. For example, किछ हमें example नबा. This, then draw along with me. किसी एग्जांपल तुमको एक्सप्लेन कर देवी तापर हमें क्वेश्चन देवी. ओके तापर क्वेश्चन देवी. तो देखो फर्स्ट कंपाउंड देखियो. ओके देन फर्स्ट कंपाउंड तो देखियो टॉप रे जो कार्बन अछि दिस कार्बन दिस इज sp3 hybridized. Okay, since it is sp3 hybridized, so it is non-planar. Since it is non-planar, then non-aromatic. बुझ परलो. हम देखिथिले कोन एठी ना प्लानारिटी थिबा दरकार और and fully conjugated थिबा दरकार. तो एठी कोन आइला sp3 hybridized means non-planar. Non-planar means non-aromatic. Here also sp3 hybridized, non-planar, so non-aromatic. Got it? Okay. अच्छा तापर देखियो. Second question देखो. Second question positive charge is there. So positive charge is there. So positive charge means it has conjugation. Positive charge in conjugation with pi bond. So it is conjugated system. So since it is conjugated system, so it has planarity. It has aromaticity. Okay. So देखियो how many pi electrons are there? So it contains 2 pi electrons. So 2 pi electron hele, it is aligning with the formula 4n plus 2 pi. So the 4n plus 2 pi सहित आसी n value 0, तो हम कौन लिख परिवा ना, this is aromatic, right? So next compound देखो, pi bond in conjugation negative charge, negative ऊपर देखो note रे लिखा है negative charge is the part of conjugation, then it is considered as 2 pi electrons for deciding aromaticity. ताली कितने pi electron है गले 4 pi electron. So 4 pi electron means that is anti-aromatic. Clear? बाकी तुम देख परिवो, it contains 4 pi electrons, it contains 6 pi electrons. So 4 pi means anti-aromatic and 6 pi electron means that is aromatic. Okay. So बाकी condition तुम first time कौन देखले, cyclic is there, then planarity is there, then fully conjugation is there, then 4n plus 2 pi aromatic and 4n pi anti-aromatic. Note down. Now I am going to write some more examples. तुमको मेंशन करिया पड़िबो एटा aromatic के नहीं. Then write I hope all of you are writing. This is 7-membered ring. Okay. So quickly note down. Total 14 questions are there, which are aromatic, which are non-aromatic, and which are anti-aromatic. Non-aromatic at all. Now, whether it is non-planar or it is non-conjugated. Quick. So try to the friend. Okay. I hope all of you written the question. Now try. Make it fast. Last 2 minutes तापर हम discuss करेंगे. तो कौन condition देखियो first cyclic अच्छी कि नहीं? So all the compounds are cyclic. तापर first condition is fulfilled by all the compounds. तापर देखो planarity is there or not. Next is whether this is fully conjugated or not. ये सब condition देखो. Okay. First of all, I'm going to write the answers. First aromatic. Compare with the answer तापर हमें explain करिवा. This is anti-aromatic, non-aromatic, aromatic, then aromatic, anti-aromatic, non-aromatic, aromatic, non-aromatic. Quickly compare with your answer. Okay. Quickly compare with your answer. Now I'm going to explain first. If you'll see in first, that is benzene. Second is naphthalene. There is 3-membered fused ring, then the name is anthracene. So benzene, naphthalene, anthracene, all are aromatic. Benzene, देखो, cyclic is there, and all the pi bonds are conjugated with each other. Conjugated system is there, and all the carbon atoms are benzene. Now the second compound जोड़ा है naphthalene. All the carbon atoms are sp2 hybridized, and all the carbon atoms are associated with pi bond. ताले fully conjugated system है ला. So ये condition पर हमें इट देखिबो, it contains 6 pi electrons, it contains 10 pi electrons. ताले 4n plus 2 pi रे benzene रे n value is coming 1 and naphthalene n value is coming 2. ठीक. अच्छा. Similarly हमें देखिबो next boron is there. So boron is second period elements and it has 3 electrons in the outermost shell. तो 3टा electron share हबो. So total केते गेला 6 electrons in the outermost shell. Boron has 6 electrons in the outermost shell. Then it contains one vacant orbital. So the vacant orbital rahila, so it is similar to this compound. Eta dekhi paribo 5 membered ring saito is similar regala. So it contains how many pi electrons? 2 pi 1 4 pi electrons. So anti-aromatic. Next, 4 membered ring, 2 double bonds. The 4 membered ring, 2 double bonds. Tale kon habo 4 pi electron. 4 pi electron mane anti-aromatic. अच्छा एठी कोन ना को कहते सीओटी कट साइक्लो ऑक्टा टेट्रा ईएनए सीओटी स्टैंड्स फॉर साइक्लो ऑक्टा टेट्रा ईएनए सो तार जो स्ट्रक्चर हैला this is the structure okay so it is non planar अब ताको कहते टॉप शेप स्ट्रक्चर टॉप शेप स्ट्रक्चर जब टॉप शेप स्ट्रक्चर हबो एटा कोन हबो नॉन प्लानर हबो देन नॉन एरोमेटिक हेगला नॉन प्लानर मींस नॉन एरोमेटिक okay next देखो so it has the name pyrrole and it has the name furan and it has the name thiophene. In pyrrole, furan and thiophene, one of the lone pair is part of conjugation. That is lone pair part of conjugation that will be considered as 2 pi electrons, so aromatic. Anhala pyridine. Okay, 6 membered with one of the nitrogen atom in the ring pyridine. So although nitrogen contains lone pair, okay, so but the lone pair is not part of conjugation. Karon pi bond is the part of conjugation. Tale 6 pi electron aromatic. So it has next 7 membered ring. The name is tropylium. Tropylium carbocation. Again 7 member and one of the carbon is positively charged. So that is containing 6 pi electrons. 6 pi aromatic. Then 8 pi electrons anti-aromatic. Okay. So here this carbon is non-planar, non-aromatic. Then here this is known as aniline. Aniline contains 10 carbon atoms. So aniline re जो hydrogen atom अच्छी here. So these two hydrogen atoms make the compound to become non-planar. Hydrogen atoms make the compound to become non-planar. So the compound non-planar है लाता कौन है जो non-aromatic. आउ এটা 7 membered ring boron positive charge. तावने ये similar to tropylium carbocation. Okay, similar to tropylium carbocation. So similar to tropylium carbocation होबो, so it becomes aromatic. Clear? Okay. Up to this, if any doubt, write in the chat box. So the point doubt achi. Okay. Student, don't write any unnecessary messages. Now, write some more compound for deciding aromaticity. Decide this, whether this is aromatic, non-aromatic, or anti-aromatic. Okay, only these. Tell whether these compounds are aromatic, non-aromatic, or anti-aromatic. Quick, only 2 minutes. Okay. अच्छा, तमे देखिबा there is a rule, write in notes. Pi bond present outside ring or joining two rings may undergo heterolytic cleavage if the rings become aromatic. Okay, note down quick. Pi bond present outside the ring or joining two rings may undergo heterolytic cleavage if the rings become aromatic. If one of the ring is aromatic, another is anti-aromatic, then the dissociation of pi bond is not possible. If one of the ring is aromatic, another is non-aromatic, possible. Okay, both aromatic, quite possible. Aromatic, non-aromatic, possible. And aromatic, anti-aromatic, not possible. Now see, ଯଦି ଆମେ ଏଠି bond break ହବ, so obviously carbon will be positive and oxygen will be negative. Carbon ଯଦି positive ହବ, it becomes anti-aromatic. So that means the ring or the bond cleavage is not possible. So it becomes non-aromatic. Here, if the ring acquires positive and oxygen negative, so it becomes aromatic. Here, this compound will be present in this form. So this is aromatic. Is color student? So this type of questions are also asked. Note down. Here, this compound is present in this form. This is plus, this is minus. So aromatic. Both are aromatic by having plus charge with 3-membered carbon and minus charge with 5-membered carbon. So it is the 5-membered achi. 5-membered joti plus rakho, joti minus rakho. So it will be joti plus rahibo, that will be anti-aromatic, and minus rahibo, that will be aromatic. So it is not possible. So it cleavage habani. So it becomes non-aromatic. Here, if again 3-membered ring plus charge aromatic and 7-membered ring negative charge, gote plus hela gote negative hobo. So that is also not possible. So it is non-aromatic. Okay, non-aromatic. Jadi a type of compound thanda, tale it is aromatic. Why? Because negative charge will be with 5-membered and positive charge will be with 7-membered. So this is negative charge, this is positive charge. So aromatic. Write down. If it plus minus rahibo, the compound becomes polar. The compound becomes polar. So likhi deo. After the heterolytic cleavage, if the plus and minus signs are associated, then the compound becomes polar. I hope up to this clear. Yes, Huckel's rule is applied. I mean, jo aromaticity check kariba. So we have to take the help of Huckel's rule. Then message likhthilo. Next. So these are the topics, these are the examples of aromaticity. Now, electrophilic aromatic substitution. Electrophilic aromatic substitution. Okay. So electrophilic aromatic substitution. Kono? I mean, aromatic compounds like benzene cannot undergo addition reaction because after undergoing addition reaction, its aromaticity will be destroyed. Then it cannot undergo oxidation reaction and reduction reaction. Same aromaticity destroy. Then reaction rahila kono? Na reaction rahila substitution. So substitution re with each carbon, then benzene dekhiba, with each carbon one of the hydrogen atom is present. So hydrogen has to be replaced by any other atom or group. So carbon hydrogen bhitere, hydrogen is less electronegative and carbon is more electronegative. Then hydrogen has to be released in the form of H+. So H+ mane seta electrophile hegala. So electrophile ko substitute kiye kari paribo? Another electrophile can substitute the electrophile. So it is the example of electrophilic aromatic substitution. It is the example of electrophilic aromatic substitution. Okay. So what are the reactions taking place under electrophilic aromatic substitution? Now there are 4 mainly, that is nitration, then sulfonation, then halogenation, then nitration, sulfonation, halogenation, then Friedel-Crafts, reaction. So it is of two types. One is alkylation, another is acylation. Friedel-Crafts reaction is of two types. One is alkylation, another is acylation. आमे सबू चैप्टर अंडर रे ए चारटा रिएक्शन को डिस्कस करिया तो 12 क्लास जोटा अछि. So under nitration आमे देखियो which is the reagent used. The reagent is concentrated HNO3 plus H2SO4. So sulfonation reagent concentrated H2SO4 or oleum H2S2O7. आपको नोट कर दियो क्विक. Halogenation it is X2 plus iron in dark or X2 plus FeX3. Next alkylation Rx plus AlX3 and acylation RCOX plus AlX3 or FeX3. AlX3 or FeX3. Okay. So which is the electrophile in nitration? That is NO2 plus. It is SO3. It is X plus, R plus, RCO plus. Right on. I think all of the writing. Over. Okay. तापर देखियो mechanism of electrophilic aromatic substitution. What are the mechanism of electrophilic aromatic substitution? So first step is the formation of electrophile. ये ला general mechanism. Formation of electrophile. Second, rearrangement. एटा सब जगह हुए नहीं केवल कार्बोकैटायन हुए. Friedel-Crafts कथा कहूचे. Rearrangement of electrophile may take place. Then rearrangement of electrophile may take place. Then attack of electrophile form sigma complex, then removal of H plus to form aromatic compound. So these are the overall mechanism. Tomorrow halogenation how, Cradle-Cavity reaction or any reaction. These are the overall reaction. Write down. I hope all of you are writing. So first is the formation of electrophile. I'm going to take a nitration. In nitration reaction, which are the reagents? In nitration, which are the reagents? Now the reagents are concentrated H2SO4 and HNO3. So between H2SO4 and HNO3, which is more stronger acid? H2SO4 is stronger acid. Tale H2SO4 gives H plus HSO4 minus. Okay. So this H plus it reacts to form NO2 plus after removal of water. It reacts to form NO2 plus after removal of water. Okay. So NO2 plus name is nitronium. Okay. That is NO2 plus is nitronium ion. So first step, second step kona? Na rearrangement of electrophiles. So ademdam koithili rearrangement electrophiles सबबोले हुए नहीं किसी specific case रुहे. So here it is not possible. Second kona? Na attack of electrophile to benzene ring to form sigma complex. Okay. So it is stabilized by resonance. So this is known as sigma complex. Then the third one is removal of deprotonation. Achha, deprotonation kahin ke hobo? Now this sigma complex is non-aromatic. Our beginning रे हमें जो नहीं थिले benzene, that is aromatic. So non-aromatic रो aromatic is more stable. तामाने compound जदि हमरो intermediate non-aromatic बनिला, so it will be converted to the aromatic. So केमती? ना by deprotonation. So हमें देखिए H SO4 minus. H SO4 minus plus H2SO4. हम जानते हैं H2SO4 is used as catalyst. here देखो last को H2SO4 बनी गला. Okay. Note down. Make it fast. Friend, any doubt up to this? Okay, good. Next. Next is sulfonation. So which is the reagent in sulfonation? H2SO4. So here in first step, self-protonation. Then H2SO4 in the presence of H plus. Okay. So it is minus water. It is minus H plus. First step. So SO3. So here the electrophile is SO3, which is the neutral electrophile. After first step, the second step is it attacks the benzene or any substituted benzene. So this is again sigma complex. Second step, third step, the sigma complex. Okay, intramolecular hydrogen transfer. So after doing intramolecular hydrogen transfer, the aromaticity will be regained. So sigma complex is non-aromatic and it becomes aromatic. So फटाफट लिखी दिए स्टूडेंट. तब aromatic halogenation देखिए. Quick 1 minute. I think clear. Next is halogenation. सब reaction में mechanism देखिए. Halogenation. So in halogenation, step 1 to form the halogen free radical. Suppose we are taking Cl2 plus AlCl3. So it is Cl plus AlCl4 minus. So which is the electrophile here? Cl plus. Sigma complex. Note down. Next, the sigma complex achi that is treated with LCl4 minus okay. So this is the example of halogenation. खाली रहिला तमरो Friedel-Crafts reaction डिस्कस कर दो अभी और 2 मिनट लागिवो सब फटाफट नोट कर दियो जवान नोट करियोटे डिफिकल्ट होची यू कैन टेक द स्क्रीनशॉट आल्सो मेक इट फास्ट नाउ Friedel-Crafts alkyl alkylation कहि दोची acylation तमे निजे सिमिलर वे कर परियो so in alkylation first step Rx plus LX3 that gives R plus LX4 minus और तुम जानचो कार्बोकेटायन may undergo rearrangement but not always undergoing rearrangement. So next कौन is attack of carbocation to the benzene ring. Okay, attack of carbocation to the benzene ring. Okay, next so intermediate achi the sigma complex so in the presence of LX3 X4 same जोड़ा हम देखते ले okay LX3 plus हमरो the hydrogen अछि similarly it R जगह RCO है जो बाकी रेस्ट सेम क्विकली नोट कर दियो right so after writing this the 5 minutes break ले जाओ then your next class will be started जब complete कर दलो take 5 minutes break and no need to sign out next class so जल्दी start हो